I wanted to explain how food relates to your immune system and what can go wrong with it. So first of all, let me tell you about the inside of your body and your immune system. And actually it is a whole system. It's not just one specific type of cell, it's lots of different cells and they all have different jobs to do. And we don't need to get into that level of complexity as to specifically what cells have what jobs, but just take it that it's like an army and it's very specialized, so different cells do different things at different times, but there are lots of them. Now so the cells that we're particularly interested in for in relation to food are called antibodies. And antibodies, clues in the name, antibody, so they are fighting against something. And what they're fighting against is called an antigen, or something that can provoke a response from the immune system. That's the way to think about it. So how does something get to be an antigen rather than just a food? Well, we'll cover that in just a moment. But for the moment, let's think a bit more about antibodies. So your body is creating new cells all the time. You know, we just think, oh yes, I am me, I'm the same all the time. Well, no, actually you're not. So different cells in your body have different lifespan. So your blood cells, for example, the red platelets that carry oxygen around your body, they live for about 3 months. And then they get worn out, broken down, replaced by a whole new set. Not all at the same time. And the cells in your gut, so that's everything from, you know, up here, your throat, to down below, all of that length of piping, that gets replaced every 3 to 4 days. So it's very, very frequent, because with the passage of food through your intestines, that causes a lot of damage to your intestines, and so therefore the cells are replaced very often to keep you fit and healthy. So how do antibodies even get trained? Do they know what an allergen is? How do they know that? Well, they start life almost like blanks. So they're created, they have a chemical structure and a chemical signature, but they're not particularly interested in anything really, anything in particular. They just wander around your body, not really doing much, just there. And then something will alert them to the presence of an invader. Let's call it an invader, a pathogen, or it could be a food. So a pathogen is something that's dangerous. So it could be bacteria, it could be a virus, or it could be food in the wrong place. So the antibody will go and have a look at that and think, I don't know, don't recognise that. I don't think I've seen that before. Is that the right thing to be in this body? So do I recognise that as self? So there is this concept of self is an academic definition, if you like, that means anything to do with you, of your body. It's called self. So the antibody goes up to it and says, do I recognise you as self? And if it doesn't, then it will mount an attack. It will go right up to it, gobble it up, kill it, you know, smother it. So that's the end of the pathogen. And in the process, it will probably be the end of the antibody as well. But before it finally gives up the ghost, it will display a little bit of that pathogen, food, bacteria, virus, whatever it was, on the outside of the cell. And it will show that to all its colleagues and say, look what I've got, look what I've got here, this bit of, let's say it's a bit of virus or a bit of gluten, let's say it's gluten, look what I've got, this is gluten. And then all the other antibodies will come up and brush past this cell and say, oh, I've learnt gluten. So then all those antibodies will be very specific to gluten. So an antibody can only recognise one thing. It's either blank, doesn't have any particular reason to go after anything as such, and then once it learns one particular pathogen, it will seek that pathogen, or it will be alerted to that pathogen forever until it dies. So the original cell that found the pathogen will die, but all these new cells that are trained will then keep looking for that one single pathogen until they die. So we have 5 different types of antibodies. We don't really need to go into the differences between them just at the moment, but the 2 that do come up in terms of, or in relation to foods, whether it's allergies or intolerances, or sensitivities I should say, are IgG, that's one type of antibody, and IgE. And the Ig, the first Ig bit of that, stands for immunoglobulin. Again, big word, you don't need to remember it, but you may come across IgG and IgE. And if you come across IgE, then that type of antibody is applicable to allergies, because that type of antibody lives for a very long time in the body, and it mounts a very, very rapid response. So certainly within half an hour, but up to 3 hours, antibodies that are IgE antibodies, and there are a smaller number of those in the body, but those type of antibodies will very rapidly mount a response to that problem, that antigen, pathogen, whatever it was, bring in all the other troops to sort of take over and do what they need to do, and we'll talk about those a little bit more in just a minute. Whereas so an IgG antibody it takes a little bit longer to sort of mount a response. It's not as quick as IgE, and it doesn't last in the body as long as IgE. So 3 years after you had a food sensitivity, for example, you could retest to see if you had any IgG antibodies, and you may not. And that would tell you that you didn't have a current problem with that food if you were doing lab testing. But if you did that with IgE, then that IgE antibody response may be in your body for life. So if you were celiac, for example, it wouldn't do you any good at all retesting sometime later, even lots of years later, because there would still be some IgE presence to whatever that initial food was. So in the case of celiac disease, of course, it would be gluten. Now let's just talk about what happens when IgE or IgG when they get involved. So what do they do? Well, they don't fight on their own, and as I said, the immune response covers a lot of different types of cells. But with IgE, the ones that we are particularly interested in is something called mast cells, and these release something called histamine. So even if you're not very scientific, you will have heard of histamine through antihistamines that you can buy in your chemist for hay fever symptoms. And you know what they do is they stop your eyes itching and your eyes running and your nose running and your throat feeling really tight and itchy. That's what they do. So antihistamine brings down all those sort of reactions. So histamine raises those sort of reactions in the first place. So working backwards, so the IgE antibody creates the circumstances under which more histamine is released. And then when that level of when a lot of histamine is released, particularly in the throat, this is where we hear about the swelling and the throat closing up, and then people can't breathe, and that's when they need to either go to hospital or they may have something called an EpiPen. And because it's in a chemical form, it goes, injected into the body. It goes straight around the body very, very quickly, straight to the areas which need it, and so calms that response before the person is actually killed through not being able to breathe. So an allergic response can be really, really serious, and if you experience that sort of response, please make sure that you go and see your doctor and get checked out, and if it is that level of seriousness, and we'll probably be familiar with that with things like peanuts, your doctor will no doubt recommend the appropriate thing for you to have.